A casino floor, 2 in the morning. A tourist hits a jackpot, lights screaming, $100,000 gone from the house in one pull. And the pit boss, watching it happen, doesn't even flinch. He congratulates the winner, comps a sweet, and goes back to his coffee. Because he knows something the winner doesn't. The casino doesn't need luck. It needs volume. Every game on that floor pays the house a few percent on average. And there's a 300-year-old theorem guaranteeing that with enough pulls, enough spins, enough hands, the average is exactly what shows up. One jackpot is weather. 1,000,000 bets are climate. It's called the law of large numbers. As the number of trials grows, the average result converges on the true underlying odds. It is arguably the most load-bearing theorem in the modern economy. Casinos, insurance, medicine, polling, every one of them is a building constructed on this law. And by the end, you'll also see the trap on its flip side. The small number mistake that ranks hospitals wrong, fools investors, and once burned $3 billion philanthropic dollars. The proof cost a life's work. Jacob Bernoulli, a Swiss mathematician, chased it for 20 years and called it his golden theorem. It was published in 1713, 8 years after he died. What he proved is subtler than the pop version. The law doesn't say, luck balances out. Remember Monte Carlo? The wheel owes you nothing, and the streak is never corrected. What the law says is that luck gets drowned. Watch the line. Early on, the running average of coin flips swings wildly. 60-40, 70-30, chaos. But as the flips pile up, the swings shrink, and the line settles onto the true odds like silt. The early luck is still in there. It just stops mattering, diluted under the weight of N. That drowning is a business model. An insurer cannot tell you whose house burns this year. But across 100,000 houses, the claim rate is nearly a constant, so they can price your premium to the decimal. The casino's 5% edge is a rounding error on one hand and a guarantee across a quarter. A drug trial needs thousands of patients because a result in 12 people is a rumor. Same law, one direction. Certainty is purchased with volume. Pollsters live and die by the identical arithmetic. 1,000 random voters can forecast 100 million, but shave the sample or skew it, and the guarantee quietly dissolves. Now, the catch, and it's the half of the law almost nobody teaches. Small samples don't just carry more randomness, they carry it invisibly, and humans refuse to see it. Psychologists call our blindness the law of small numbers. We treat 5 data points like 5,000. Here's the brutal real-world version. Rank American schools by test scores, and small schools dominate the top of the list, which convinced a foundation to spend fortunes breaking big schools into small ones. But small schools also dominated the bottom of the list. Nothing about small was better. Small just swings harder in both directions. Statisticians have called the formula behind this the most dangerous equation in the world, because not knowing it keeps costing real money. The same illusion ranks small hospitals as miracle workers and death traps, crowns fund managers after 3 good years, and convinces you a restaurant with 2 5-star reviews beats one with 4,000 4.5s. Pause and check yourself. What's the smallest sample you've trusted this week? So here's the discipline. Before believing any average, any rate, any ranking, ask N. How many trials is this built on? Below a few dozen, treat it as an anecdote. Below a few hundred, as a hint. And never compare small units against big ones on the same leaderboard. You'll mostly be ranking their variance. The house wins because it knows exactly this. Bet like the house. Put your money, your trust, and your decisions where N is large. And next time, if more data makes decisions better, more options should too. Right? A table of 24 jams, a wall of 500 funds, and the strange science of why choice itself can paralyze you. Including the part of that famous study nobody quotes. Hicks' Law. Next.